All right, we're going to find the 6 trig functions given that the terminal side of angle theta goes through this point right here. Okay, so let's see what that looks like. Right here, -7, -24. We know that that is in quadrant 3. And the lines down here, theta, if it's in standard position, would have been all the way around here. But we don't really need to know that to solve this. What we need to know is if I'm using my reference angle right here, theta prime, because it has one side on the x-axis, and we make our right triangle right here, we can use Pythagorean theorem. All right, and here is our triangle. We know that our x value is -7 and our y value is -24. Okay, we're going to use Pythagorean theorem until we find this red line, which is also known as the hypotenuse, and then we'll be able to find our 6 trig functions. So this is not on the unit circle. The red line is not 1. We are going to use our a squared plus b squared equals c squared. All right, let me get my calculator. All right, -24 squared, negative times negative is a positive 576, plus -7 times -7 is 49. 576 plus 49 is 625. Oh, isn't that nice? 625 is a perfect square. Square root of 625 is 25. So when you get a problem like this, you might get one of these known triangles, like the 3, 4, 5 triangle. All right, now we know what we need to find our sine, cosine, and tangent. Sine is opposite over hypotenuse, which is -24 over 25. Cosine is adjacent over hypotenuse, which is -7 over 25. Tangent is opposite over adjacent, which is a negative over a negative. It's going to be a positive 24 over 7. And then these 3 down here are the inverse, not the inverse, the reciprocal of what you see above. So the cosecant is, remember, C goes with S and S goes with C. Cosecant of theta is -25 over 24. And the secant is -25 over 7. And then the cotangent is 7 over 24. There we go.